All right, let's go. Here we are. Welcome back to whoever's tuning in again. Um, so what I want to do now is finish what I did at lunch or this afternoon, which was to add assignment to Monkey. So to recap, what I set out to do was to build this into Monkey. We already had this, let a equals 1. That worked. We already had the puts, our built-in function. We also already had this, and we didn't have this. And this is the example actually. We had this, we had functions, but we didn't have the assignment. So what I did was I added, hello Klaus, somebody's actually watching. The internet is amazing. All right, so what we did was we added the equal sign to the lexer, we added assignment to the parser, we added it to the evaluator. I finished with a commit. Let's take a look. This is what I did. As you can see, there's a to-do hacky here. There's an eval assignment. There's another to-do, both of which I want to fix now. And we added a bunch of tests. And when I say a bunch of tests, I of course mean a single lone test. Oh, I need to read something in the chat. Cheers, man. That's a nice message. Can also, that's a cool message. That makes me smile. Nice. Okay, so the state of this last commit was that, let's demonstrate it again. We were able to do assignment. So if we build Monkey and we see a let a equals 5 and then say a equals 10, what you're going to see now is 10 being printed to the REPL because I decided that assignment is an expression. So this is actually an expression statement and it returns 10 and it now assigned 10 to a. So if I now do puts a, it prints 10, the reassigned value. Okay, the problem is that this does not work across scopes, meaning, I'm going to switch to notes, meaning that this here does not work yet. Because this here is the global scope and this here is a different scope. And it's independent of whether it's a global scope or a nested local scope. It just doesn't work across scopes. So we need to fix this. Then we also need to make sure that assignment to hashes works, then assignment to array indexes. And then this, I think we can fix closures by implementing assignment across scopes. I'm not sure yet. The whole thing, I thought about it this whole afternoon, and the whole thing it's tricky. As soon as we get to the compiler, I'm not even sure I should attempt it, but a lot of things fall apart when you start to introduce assignment. So there's a question in the chat, do you pass a scope context somehow to each local scope? Depends. It depends on who's asking. If we're talking about the interpreter, I'm going to get to this. We do have a context. The context is the environment. But what you're getting at, what your question is exactly the thing we need to fix now. So let's jump right in. I do have a failing test here. This is what I came up with. So we say let a equals false, okay? Then we create a new function, which creates a new scope, right? It's this one here. And in that scope, we assign true to a and say a equals true. Now, a does not exist in the scope of this function. It exists in the outer scope. So the lookup works because, you know, Monkey could do this. You could always look up variables outside of the current scope. The problem is assigning doesn't work, which is why there's a big to-do here on the left. So if I run these tests, you will see at the bottom here, this is the test message, or the failure, right? Object has a wrong value, got false, one true, which is, I actually created this assertion. But the problem is that we expect true to be returned here in this test, A, and it's not. False is returned. So how do we go about fixing this? Here is what I implemented, right? This afternoon. This is the whole function. Eval assignment. So we get in the left and the right expression. Left is like, if you say A equals 5, then this is left and this here is right. Right? Like this. So what we do is we check that the left is an identifier for now, right? It could also be an index expression if we want to assign to an array. I'm not sure yet how that works, but we'll get to it. And then we do a lookup in the environment and say, do we even have something in the environment with that name, right? Because in Monkey, we do not allow assigning to an undeclared name, which you can do in, you know, in Ruby. You can say A5. There's a declaration and an initialization is the same thing. In Node, you can do the same thing. You can say A equals 5, or you can say let B equals 10. It's the same thing. What they do under the hood is they emit a let A, or I don't know, maybe no, not a const. That would make sense because it's not a const, but they emitted let A, and then they assign a value to it. In Monkey, we're not gonna allow this for now. Let's see. So we then look in the environment and see if we have a variable in the environment with this value, and if not, we return an error. And then we evaluate the right-hand side, so the 5, right? It could be something like 5 plus 5, it could be something like 5 plus, you know, whatever. It's an arbitrary expression here on the right, and we want to get the value. If that is an error, we return the error and don't do anything. So it's an early exit. And then, this is the naive solution, we set in this environment the value to the new value. So what we need to do is, instead of doing this, and I'm going to open this, let's jump to the definition. This is environment get. Instead of transparently, or well, not transparently, looking up the value in any environment and getting just the value, what we need to do is we also need to get the environment in which the value was defined, because in that we need to define it, reassign it, sorry. We cannot just assign it in the current env because, you know, this is the problem, right? We do assign a value to the identifier in the current environment, but that's not what we want. So in this test here, what happens is that we do assign something to the name of A, but we set it only in the local scope, right? So how could we, let's demonstrate this. So it should work like this. So we say let A equals false. Now we say let my fn equals fn A equals true. And we do puts A, right? And then we call my fn, which will now reassign true to A and print the value, the current value, the new value of A, right? So it prints true. But if I now do A, it says false, because this last A here, this is still this one. And this here, sorry, this reassignment here is just for the local context. So what we need to do is we need to do the assignment in the correct env. And what I thought about was changing the signature of env get to not only return the object, but also the env. So like this, right? And then we could say like this, and then we say no, that's not. Wait a second. Env and env equals e. So this is the one where we look through like this, and then we return env. I'm just hacking stuff together here. So why is this still red? Okay, it's not. Okay, so now a bunch of things should fail to compile. Let's name this original env or something, and then we say, you know, in the original environment we assign this value. It says undefined. Why is this undefined? Oh yeah, of course. Like this. Problem is there's a bunch of other things. So eval identifier here, we're gonna ignore the env that's returned. Is that it? Was that the only two calls? Oh no, boy. Oh boy. Okay, I don't know if this is a good idea. But why not? So wherever we have these calls and forget, we're gonna ignore it. So I'm now just fixing tests, which is nice when the compiler helps you. So now let's run them again. I don't know if I got... Nice. Okay, I got all of them. Did I get all of them? Did we just make the test pass? Let's see. Just be sure. Nice. Okay. Okay. So now that means we can sign off another thing. We can sign off this. Assignment should work across scopes. Boom. That's cool. Okay. So let's go to the evaluator and see if we can write some more tests. You know what I want to try? Let's try something. This is interesting. Let a equals 5 and then say a equals a plus 1. So we increment it. So that should return 6, correct? Cannot use type. Oh yeah, because our tests just expect a bool. So we need to kind of boost them up. Do we need this? Nope. Case bool. Yep, let's see. I need to change this test. I bet I can copy something from somewhere. Test bool. No, this is the first instance where I do this. Does this work? I bet it doesn't, right? I need to probably cast it. I need type assertion, that's right. In 46. No, oh, yeah, I'm an idiot. So this is it. Yeah. This is what happens when you copy and paste. So expect it has the correct type. Sweet. Okay, that already works. That's cool. We get a lot of stuff for free in our interpreter versus the compiler, where all of this is a lot trickier. Okay, so what should we do next? We could make a commit. That's a good idea. Nobody said this. I just said it. Let's do a little commit out of this. We can always look at the pull request in the end and decide whether this, this interface is what we want to keep. Yeah, let's remove this comment. Eval assignment. Oh yeah, we need to fix this too. This we can remove. So, yep. Yeah, that looks good. Don't want to commit this. Don't want to commit this. Yeah, I do want to commit this. Okay. Work across scopes. Right, next milestone. That's cool. Okay, so now why is the... Okay, the working directory is dirty because I did this little hack here to get the interpreter up and running in the REPL instead of the VM. And I do have my to-do file. So, assignment to array. Let's do this first. I bet there's a more elegant version, but let's see. So, let's say we have an array, and that is 0, or we say, yeah, foo bar foo. Okay, and then we say A0 is, I don't know, monkey, and then we say A0. Oh, you know what? Let's use integers because I'm too lazy to change the test assertions to strings. Okay, we have 999, 888, and then we assign to 777, and what we want is 777. Let's run these tests and see. Cannot assign to something that's not an identifier. Nice. We wrote this. Right? So what should we do? What should we do? What we could do is we could say, switch left type and say case est identifier, and then move this in here and say default return new error, cannot assign to something that's not identifier. Yep. Undefined ident, yep. Because ident is left now. So now all of the tests should still pass, except the new one, of course. Let's take this one out for a second and make sure. Yeah, all the tests pass. So let's take this one back in. So now, obviously I went with the option of saying, we evaluate what's on the left side, depending on what type it is. So if it's an identifier, we look it up in the environment to get the original env and then reassign in that environment. So now we can say AST and say index expression. And then the question is, so an AST index expression has left, which is an expression, and the index, which is an expression. So what we need to do is we need to evaluate both of them, but not fetch the value. So let's see. Eval index expression. This is what we need to do. We need to evaluate left and index. And then what does eval index expression do? It says if left type array object and index type. Yep. Eval array, and it returns an object. The problem is we need to kind of duplicate this. We need to duplicate this. Okay, so what we're going to do is we're going to do the stupid thing, and we're going to just, you know, what's the word for the thing that's being indexed? Indexed. I don't know. What's that? A target? No, that's not. It's not the target. The target of an assignment is the thing that's being indexed plus the index itself. So let's call it indexed, and then say node and left, and then indexed, and then we have left index. Yep. Okay. So it says missing return. Let's return null, so the compiler doesn't complain. Tests should still fail. Now they fail. They fail with a better message, because now we return null, so this thing doesn't throw an error, but it just doesn't do anything. So now we can make it work. So how do we do this? We do have the thing that's being indexed, which is in our case an array, and we have the index, which in our case is an integer. So now we need to do the same thing that we just saw in this eval index expression thing, and we need to do kind of this. Let's copy this because I'm sure we're going to use the whole thing again. We can refactor this later. The thing is, we just need to do left needs to be called indexed, and then this here we need to we need to copy. Yep. So, you know, make it work, make it fast, blah, blah, blah. No, make it work, make it clean, I guess, and then make it fast. So this is indexed. So now we have the array object, we have the index, which is the unwrapped value. We check for this. If the index is out of bounds, we just return null, which is weird, right? Like what does Ruby do? Say you have an array and you say a0 equals, it just grows it, right? Yeah. See, that's the tricky stuff you get into. What does node do? JavaScript. Oh boy. Oh boy. You know what? We can always add this later. Let's not do it. Let's return an error here and say if the index is out of bounds, index out of range. You know, let's do this for now. And then here, this is what we need to change, right? So we need to evaluate this again. This is the right-hand side, right? And then we can say we assign it and say this is the value, and we return the value. Yeah, and here we return an error. Okay, now let's run the tests. Boom, they pass. That's nice. Sweet, okay. So we definitely need to clean this up. Because there's a lot of duplicate code, I'm just gonna answer a tweet. Okay, so there's another question in the chat. I tried to implement the for statement in Monkey before, but I stopped to do it because handling the environment was hard for me. Which I get, because a for loop creates a new environment in the body in which you add the counter, but it doesn't exist in the outside environment. So it can get tricky. I did implement while loops with this, but that doesn't create a new environment, right? It just evaluates the expression in the current environment. So let's see how this goes, and then we can talk about implementing the for loops. Okay, so let's clean this up a little bit. Obviously, this is verbosity that we cannot easily get rid of, but this we can. This we can. What I'm wondering is, could we return a pointer to this? And then just so let's take a look at the other. So this is basically the duplication, right? This here is the eval array index expression function. It does the same thing. You have an array, it unpacks it into an array object, gets the index, gets the integer value, and then checks that the index is not out of range. How can we remove the duplication? This here is a read function. All it does is it wants to fetch the value, and if it cannot get fetched the value, it returns a null. Here, there's the difference that if the index is out of range, we want to return an error. So we could do something like this, right? And say I'm not sure if we want anything. Like, yeah, we can do this also here. Right. Here it's indexed. What I wonder is, could we do something like get array element, and you pass an array, an index, and an object, and you get back a pointer to an object. Problem is, let's try this. Why not? What is null? Null is already. Yeah, Keegan is right. Nice, Keegan, for you to show up. Yeah, I want to return a pointer to a pointer. The thing is, I do have. These are interfaces, so this makes it a bit tricky. You can do pointers to pointers in Go, which is kind of what I was trying to do. But object is an interface, right? And I'm wondering, apparently, I don't know, apparently it's not straightforward to return a pointer to an interface which is implemented by a pointer. What's the answer here? You know what? Let's let's at least save another line here and do this and say this also returns this. And yay, we're gonna return 3 values, and then we can do this. And this, and let's remove this again, and here we say max, and then we can remove this, and then up here we can also remove this, and now we have this. So now there's not that much duplication because we do different things. If we're out of range, if we're reading, we're just going to return null. If we're assigning, we're going to return error. I'm still not super happy with this, but that's honestly that's a fault of the original design. And if, you know, go ahead pattern matching, that would be nice. All right. So I'm back online. I just checked. Need to check the microphone. Okay, so this works. I don't like this that much. It's a lot of code. We could pull it out into separate functions, but I don't think it makes a lot of, it would just be hiding stuff, right? I mean, yeah, we, you know, func eval array assignment or something, and we say array index object, and we return and we return a value, which is an AST expression, and the env, which is an environment, and we return an object, right? So then we can just move all of this index left. Wait a second. Where was the? It's right. And env. We can just move this here. And cannot use eval right env as. Yep. That's a better name, actually. Why is it undefined env? Why is that? Object environment. Jesus. Let's see. Okay, so we kind of pulled this out. Right, all the tests should still pass. Let's make a little commit because, you know, quick save. And be sure that this works. We want to add this not. Check what's in the commit. Make assignments to array index expressions work. Right. What should we do next? I know there's still this, so let's tackle this. I left a comment at lunch that this is hacky because before I implemented it like this, I thought I'm gonna introduce a new type of AST node for this and not use infix expression, but something like assign expression. And then in the parser, I would, you know, I would implement a separate parsing function that would parse an assign expression into an assign expression. I do think that this is hacky to reuse the AST infix expression thing. Technically, an assignment is an infix expression, but you know, it's the same here. Like we use the parser to also pass a call expression, but this doesn't return, you know, an AST infix expression. It returns a call expression. So let's see if we can get this working with a separate AST type. Let's go to AST index expression. We're just gonna copy one of these types. Yeah, and just index. Yeah. Let's do this. we say left, and we say this is the target, and in string format it looks like the target as a string, then this, and then the value as a string and the closing paren. Right? I'm going to keep running the tests because I like them. They're fast and easy to run. So now that we introduce this new thing, the goal is to have all the tests passing at all time, which they do, but with a new AST node. Okay, so this is just a refactoring, so to say. So what we need to do is we need to go into the parser and say, if you come across an assign token, and we're going to move it down here because it's the newest one, we want to say parse assign expression, right? Well, what we're going to do is we're going to copy this and just, say call parse assign expression, token is the current token, function. Now this is the thing that's being passed in by the parser. This is the left hand side, so this is the target of the assign expression. So we can assign it here and say target is this. And now we need to say we're expecting, let me see, yes. Yeah, we kind of need to do something like this. I'm just trying to kind of need to do this and say if the next token is not an assign, which is this, do nothing, return null, which, yes, there's no proper error handling in the parser. Otherwise, expect peak, what it does is it expects a type of token, and if it's there, it consumes it, right? So if the next token is this type, then advance to the next token, right? So now we're sitting on top of the equal sign, and what we can now do is we can parse expressions like this, and we can say x value is this, and that parses the rest of the expression. Now why is this still red? Because something, go please, whatever. Okay, test fails. Why? Token assign. Oh, I bet it has something to do with precedence stuff. By the way, yeah, I wrote this interpreter before it was, I don't know, when was T-helper introduced in Go 110, 111 or something? So that you don't have T-helper, which means you need to get to the test manually. So let's see what fails. Parse an infix expression. So let's comment out these out. Okay, so wait a second. Did we do something wrong? Sorry, let's go to the parser. Assign expression. Are we already sitting on it? Oh yeah, of course. Oh yeah, Jesus, that's damn it. Yeah, okay, I get it, okay, I see. I see. So when this function is called, when this method is called, we're sitting on top of the equal sign. So if you have an expression like a equals 10 or something, as when this is called, the current token, p cur token here, is this equal sign. So the convention of this parser is that you always sit on the first token of the thing that you want to parse. So if you want to parse, a list, an array, the parser needs to sit on this first. Like, I don't know if you can see this, but it needs to sit on this bracket here. So you can call the parse array literal method. And I forgot all of this because it's been some time that I worked in this parser. So when we arrive here, since we registered this as an infix parse func, we get the left-hand side of the operator, which is our equal sign, passed in, which is the target. And the current token is the equal sign. So what I just tried to do was, the first thing I tried to do was to say expect next token to be an equal sign, which produced an error because the next token is not an equal sign. And then I assumed I could just do this and parse the next expression, which is the right hand side, which also doesn't work because I'm still sitting on the equal sign. So we need to call next token, which advances, it's the parser, and then we need to call parse expression. So now, in order to prove that I just didn't talk some crap, let's run the test. And nice. Okay, so the problem is the tests actually pass. Well, they don't pass, but I think they should. The problem is our assertions are a bit strict, so to say. Famous last words. So, where's this called? It's up here, right? Yeah. So, we could pull this out into a separate test and say test parsing a sign expression, and we're just gonna keep this interface because I like this interface of saying this is the input, this is what I expect the left value to be. We can rename this and say target value, and we can right value is correct, and we want this to be an index expression, and then we're gonna delete all of these, and instead of doing this, we're gonna copy some of this out and put it here and say it should be an assign expression, which means and we want to make sure we don't want it this. Let's continue here. Continue. Well, here it doesn't matter actually. It's the last thing in the test. If the operator is not, what, we don't need this. That's not a good use of our time. And this is the statement. No, wait a second. An expression statement has what? An expression, so we need to say like this, and then target, this is TT. TT left undefined. Oh yeah. And this is right value. Okay. Expression is not an AST operator expression. Well, this is the old test failure. The question is, what's the error here? So let's open assign expression right undefined. It's value. Okay, let's see. So I'm now running the old test parsing, so we can remove this here. So now the old test should work. It does. And now let's run all of them. Nice. So all of the tests pass. Error F on line 270. Nice. This is why I stream this stuff. Why should I check it? Yeah. Yeah, what's wrong? What's wrong with the error F? Oh, yes. Jesus. Yes, it should be the sign expression. Thank you very much. You wouldn't... Nobody would guess how many of these were in the book when it was already in the print edition. Because I've renamed some of the types before publishing the book. But when I did the renaming, I obviously didn't update all of the strings or missed some, and that is why there were wrong test assertions in the first printed version of the book. So yeah. Okay, so this test it's pretty that's a lot of code for just this, but I guess it's all right. We can add a bunch more. We can say, just to make sure that precedence is working correctly, and say, target value. No, wait a second. Our test setup wouldn't work with this either, right? Yeah. Because if I now do this, and then I expect this, then this is not a literal expression. So yeah. Okay, let's keep this for now. So we do have parse assign expression. The problem is why a go test? The evaluator should fail, right? Exactly. Because we don't evaluate the new assign expression in the evaluator here. So now we need to remove this. We're gonna say case AST assign expression. That's wrong. I'm gonna say this, and this should be here. And eval assignment, and we do have target, and we have a value. Sweet. Nice. So let's run all of the tests, and all of them pass. That's nice. Okay, so we can do another commit. We want this, we want this, we want this. Don't want to commit this. This is good. This is good. Yep. Yep. Okay, this is our full commit, and say use AST assign expression instead of AST infix expression. All right. So now the next thing, checking this off, the next thing we need to do is assignment to hashes. This should be a walk in the park, as they say. But you'll never know. The thing is, I'm a little bit, nervous because everything is pretty easy in the interpreter, because you have global state in a way, you have these environments you can pass around. You have all of the stuff at hand, you have the AST at hand, and you can just mangle stuff around. If we were to implement this in the compiler and the VM, things would get tricky fast, because you have the compile time and runtime separation. At compile time, you have a simple table, and you can look up where stuff is defined, and you can see, yes, this assignment would assign this value to this local var. But since we don't do escape analysis in the compiler, we don't know whether the thing that we're assigning to will be in the scope as soon as we're assigning it, and all of this stuff. And at runtime, you have closures, and closures, per definition, are a runtime thing that captures state. And time plus state always makes for tricky bugs. So I'm kind of nervous. That doesn't mean we're going to implement this. I think we should just implement the hash stuff. And then, I'm looking at the watch. Maybe let's call it a day after this for the first day of vacation streaming. Okay, so our to-do says assignment to hashes is next. So let's do this. Let's go to the evaluator, test, and say eval assignment expression. So let's use a hash here and say h, just because the a was getting boring. Let's say h, and let me just check something. Hash index expression. So these are the tests for the hash index expression, and I just want to make sure how this works again. Yep. All right. So our hash is gonna have, I don't know, 1 is 1, 2 is 2. We're gonna use strings, and then we're gonna say 1 equals 999, and then we're gonna say 1, and we want 999. So now if I run this test, what's gonna happen? Exactly, it's going to throw an error because we built these assertions into the evaluator and said Jeez, that's wrong. So now the test assertion is crashing because the return thing is not an integer. We get an error. Yeah, we could make this nicer. We could make this nicer, and I just had this idea. We could say if error, okay, and say object is an object error, and it's okay. Then we can just say get error. Let's say error message. Else this. Nice. That would be a better error message. But let's just take this out again. Yeah. So somebody commented in the chat that yes, closures are hard, and closures are truly, truly hard. They're so hard that I thought I had them nailed down for the monkey compiler and the VM. And then half a year after I released the second book, I found a bug that when you define recursive functions that involve closures, they just don't work. And fixing that bug was non-trivial because I had to fix this in the compiler and in the VM, and I had to rethink how values are created at what time and when they're being returned and all of this. Like closures at first glance look like once you get them, you think, okay, I get it. But there's a lot of edge cases involved and a lot of tricky stuff. And the funny thing is, the tricky stuff is not tricky stuff that you run into like once every blue moon. The tricky stuff is things that you kind of expect to work, but you never consciously think about them as the user of a language. But when you implement the language, you need to consciously think about them and actually implement them and make decisions and kind of think through all of the edge cases and tricky stuff. Yeah. Okay, so what does the test say? Now that we're back to our ugly error message, it says index operator not supported. Index operator not supported. So this is where it comes from, right? We're back here in our eval assignment, and now we need to copy another piece of code from the eval index expression and say this, and go back here, and then say eval hash assignment. I'm just making stuff up here, and say env and write. Let's use the same index write. Let's use the same convention here, and we're gonna copy this function. Yes, copy is bad. Say let's hash index write and return null for now. I just want to get this to work. This needs to be indexed. So now if I run the tests, they should fail because we'll get the wrong object back. The error message is gone because you basically turn the assignment into a no op. So eval hash assignment just returns a null, and now we can think about how we actually implement it. So let's look at eval hash expression. So this is how we do it. So this is how we implemented hash index expressions. We assume the indexed thing is a hash, which is, let's jump back to what we did. The indexed thing is a hash. That's a safe assumption to make. Then the key is an object turned into an object hashable, which is an interface, which means the thing implements a hash key method, which is, again, a valid assumption to, a valid thing to do here. So now we have the hash object and the key. And then why is the Twitch chat reconnecting all the time? I don't know if that is normal or not. Okay. So we have the hash object and we have the key, and this is the pair because we save them as pairs. And a hash pair has a key and a value, which is great for us because this means we can do some refactoring. We can say pair value equals the right equals eval right, and we need to pull this out of these functions. I don't like having the eval inside this other thing. This. I don't like this. Pair value equals value. I can return pair value. So now if I run the tests, they fail. Why? That's interesting. Evaluator test. Oh, I get it. Because this is a struct, it's not a pointer. Right? So what we need to do is say I don't like this. But yeah, the tests pass. I really would have liked if yeah, that's what I want to do. I want to also get the pair by ref, like add a pointer to the pair. Question is, it would introduce another level of indirection, but let's see. Okay, so the tests pass. Let's make a commit. This is what we want to commit. Eval hash assignment, that looks good. Yep, no. Make hash assignments work, simple version. So let's see if we can make this other thing work. What if pairs was, a map containing pointers to pairs? Let's run the tests. They should all crash. Not all of them, but some of them. So the evaluator crashes. Cannot use pairs. Yep. Because here. Let's see. In the VM. Oh boy. No, we can also do this here. Just use pointers. Sweet. So now we could, let's close the VM. Let's open evaluator tests. So now we can say eval hash index expression. We can make a function called func get hash pair. And we say hash object, and it returns, what is it? Pairs is object, hash pair, the pointer to an object, hash pair, and a boolean, right? So what we need to do is basically return this. Wait, what? Now each value is allocated separately on the heap. Why not do pair? I'm not sure you can take the address of a map index. So your idea was to do this. Let's just say this, right? And it says here at the bottom, cannot take the address of hash object pairs. That's the whole issue. Yeah, so this would be cool. That, well, in one sense, at least in this case, it would be cool if you could take the address of the thing in the hash map, in the map itself. But that would, yeah, that would kind of circumvent Go's memory management, because you could pass by, I don't know, the interface, and maybe also change the value in there, and I don't know. I think you have thread safe data structures like sync map, and that has the same interface, and in that case you want to go through the official interface without taking pointers and reassigning values to them, so that it is thread safe. But yeah, that would be cool. That's now the second instance where we're kind of dancing around Go's treatment of pointers and interfaces and struct pointers and all of that stuff to kind of make things work in a way. Yeah, so what I wanted to do was build this get hash pair thing, and is in hash pair, does it implement? It doesn't implement the object interface. Why is this pair? Okay, should be this, and then you return pair. Okay, this should work. Let's do this. We're kind of hiding the error here. Do not hide this error. So yeah, now with get hash pair we could do like this, but the tests fail. Yes. Yeah, okay. This is ugly, but let's, what's their message? This. do this. Now we can do this. And if is error, return error. If it's not okay and we haven't found it, return null. Okay. Where's eval hash assignment? So now we can do the same thing. Yep. Sweet. Let's check if all of the tests are passing, and I think they are. Okay. Let's commit this. Yes, yes. Yep. Yep. Nope. Yep. Yes. Did we forget anything? Nope. Use pointers to hash pairs in hashes to make use of mutable values. So there was a question in the chat, what other ideas I have for Monkey, and I have a lot of ideas. I just don't get around to implementing them. But just off the top of my head, I someday want to try out and build a Monkey to WebAssembly compiler. I want to try and use LLVM as a backend for Monkey. I want to add some more language constructs for Monkey. A lot of that stuff, optimizations, JIT compilation, and just saying this now, I noticed that the stuff I'm interested in is mostly virtual machines or compiler back-endy stuff. I'm not that interested in adding new language constructs, such as concurrency or I don't know, pattern matching or something, which, well, this is the one example that I would be interested in, but I'm very much interested in, performance and how stuff is implemented on the back end. The thing is, though, for things like LLVM, for example, or JIT compilation, Go kinda is not the best language, as in Go has a runtime, which makes it doesn't make it harder than in other languages where you don't have a runtime, but it does make it easy to compile and execute just compiled code at runtime, because you have a garbage collector that you need to tell about the stuff that you did. You have fences in memory, so you cannot do pointer arithmetic in Go, so you cannot easily break out of this runtime harness. That stuff is kind of easy-ish in Rust, or it's definitely easier in C and C++. So yeah, this is kind of what was blocking me. If you want to do JIT compilation in C, for example, you just mmap a piece of memory, you set the executable bit, you dump code in it, and then you jump to it as the easiest version. That you have to do a lot of things yourself, of course, but in Go, it's not that easy to, for example, do an mmap syscall and set the executable bit on a piece of memory. And if you then want to jump to that and execute it, that's not as straightforward either, because then you're leaving the runtime, and then you get into all of this, C, Go, and Go interface or Go ABI thing world. And yeah, if Go, for example, had a better assembler, meaning with an assembly language that is more closely related to other assembly languages, and you could call it at runtime, things would be easier, I guess. Then we could just emit assembly code in our VM, compile it, and execute it. But yeah, the Go assembler is a pretty unique thing, and it's not easy to understand, and it's not really documented, and all of the documentation and blog posts that exist on it are relatively old and outdated. And long story short, there's a bunch of stuff I want to do, but it doesn't fall into my lap, and I need to work harder to make it happen. And you know, I haven't gotten around to doing it. All right, what's next? I think we can check this off, assignment to hashes. And let's see. Didn't I leave? Oh yeah, I said I want to take this out. So we do have eval hash assignment, and we do have, that's ridiculous. So what we're gonna do is we gotta pull this out, and we're gonna pull it here. This is the it makes for a better interface. The problem is that we now evaluate all of the things before we do the type check, which is weird-ish, I guess, but also not something we should maybe get into right now. So eval hash takes, now we have 3 objects. That's pretty nice. We don't need this anymore. And eval array assignment is the same. We don't need this anymore. All we need is another value, and we can delete the rest. And that's it. Boom, all the tests are passing. That's pretty cool. Okay, so we're gonna say get add evaluator. It should be just these changes, and just to make sure we run all of the tests, do this. And say refactor code at tiny bit. All right, I'm also going to push this. Yeah, I now streamed for nearly 1.5 hours. I think I'm going to call it a day. But just to, end this, let's look at the PR. I think I can open browser window, so you should be able to see this. So this is my private monkey repository. There's a bunch of different branches that I experimented in. So this is the while loop branch that I was working in this afternoon and that I branched off of. I don't think I need to branch off of this. I don't need anything that's in while loops, but it doesn't hurt. And this is the end result of today. Plus 240 minus 24. That's wrong. God damn it. Okay, so let's fix this. AST, assign expression. That's why you shouldn't trust comments. Okay, so GitHub is pushing. Let's reload and let's see. Yep, this is our assign expression. We changed the interface of the env get call. So now it also returns the environment in which the value was found. In our evaluator, we evaluate the assign expression. Eval assignment, if it's an identifier, we get the original environment in which the value was defined. If it was not defined, we throw an error, which is not what JavaScript and what Ruby do, but this is what we do for now. We evaluate the value that we want to assign, and if it's an index expression, we evaluate the thing that's being indexed, the index, and the value, type switch, array assignment, hash assignment, evaluate these. There's a bunch of helper functions here that we introduced. We changed the pairs in a hash to be a map of pointers, so we can mutate them in place, which is fine. I don't know if this has any consequences that I didn't think of, but let's see. Yeah, there's tests. They all pass. The formatting here is wild, but let's not mention it. Macro expansion, we had to fix this call. Here we had to fix these calls. Get, here's the env, here's the env. The new thing that we're going to return, here's the new interface. 3 return values now. Here's the mutable hash pair. And here's the parser. 14 lines, that's pretty neat. We introduce this new precedent, which is the next to the lowest precedence, because you don't want stuff to bind that much. We put it in the precedence table, parse assign expression. Here's the method, tests. Not a lot of tests, to be honest, but yep. So yeah, this is the other test that I didn't show in this stream, but I added at launch, which makes sure that, you know, this is parsed correctly, that if you have an index expression, the index expression, you know, this, I don't know how it could, like this could be kind of parsed as a thing if the precedences were wrong, but this is correct. Okay, and here's another thing. Sweet, so I'm gonna hit my, oh, I cannot approve my own thing. So I'm gonna leave a nice dot on this. And with that, that's it. Thanks for watching.